Hello everyone, I'm going to present our work on cross-city PUI recommendation. This is a joint work between Tsinghua University and Tencent Company. PUI recommendation is widely used in location-based social networks such as Yelp and Gnova. By recommending new PUIs to users based on their visiting behaviors, it can not only improve the user engagement, but also bring potential profits in commercial perspective. In previous work on PUI recommendation, users' history recording is utilized to infer or suggest a new place. Lots of side information like geographical location, social connection, and temporal effects are leveraged to improve recommendation performance. In its domain, a special but important theory is cross-city PUI recommendation, which is to recommend a new PUI for users who have limited records in a strange city. However, one of the most challenging problems for cross-city PUI recommendation is the sparsity of interactions between travelers and PUI in current unfamiliar city. Currently, there is no general learning framework on handling this problem. Our work targets for this important and potential practical problem. First, let's take a look at the data sparsity issues. We use three real-world PUI checking datasets which contain user visits in both hometown and non-hometown city. Tencent WeChat is the biggest online social networks service in China. Users can check in with a WeChat mobile app, which is known as Moment. We can users check in records in 3 Chinese cities, Beijing, Shanghai, and Tianjin. Yelp dataset is Yelp Challenge dataset 3 that contains user PUI checking records in more than 100 cities. As shown in Table 1, we can observe that the number of travelers visits in current city is about 1 magnitude smaller than both the number of local visits and that of their own visits in hometown. If these two parts of information, the travelers' visiting behavior in hometown and locals' visiting behavior in current city, can be handled properly, then the recommendation performance of cross-city travelers can be largely improved. To relieve this sparsity problem, 3 types of methods have been considered. First, a direct solution is to transfer knowledge from the hometown into current city. However, for cross-city PUI recommendation, it is the knowledge about user interest that should be transferred, while above work focus on context-based knowledge such as the semantic feature of locations. Second, with the close relation to cold start problem, the strategy issue of user PUI interactions in current city can also be avoided by introducing the content information of PUIs or borrowing the PUI preference from friends. However, users tend to have different interests, while they travel in different cities that have different urban compositions, known as the phenomenon of user interest drift, which is missing in this method. Therefore, the third type of method are proposed to consider user interest drift. Although the user interest drift is common and reasonable, it should be noted that users still have some interests that are invariant among different cities. Therefore, cross-city PUI recommendation should also consider this phenomenon of user interest transfer. Here we demonstrate the necessity of modeling both interest drift and transfer by data analysis. A native Shanghai person traveled to Beijing. His favorite is still theater, indicating an interest transfer, but the category distribution gap between different cities implies the user's interest on PUI is related to a specific city and necessary to drift. To combine both two effects, we proposed a general PUI recommendation framework with user interest drift and transfer called PIUDIT in order to learn from both cities. Based travelers checking records in current city, their previous records in hometown, as well as the records of other locals, are also leveraged. To the left 3 matrices are historical records, which turn into the latent vector by matrix factorization. User vector is composed of intrinsic and drift parts, and the PUI vector is separated from travel and local. Then, by multiplying the travel vector and the current PUI vector, we get a predictor matrix where all recorded user and PUI pairs will have a preference score based on which a recommender can build. With the abundant user interest knowledge learned from the dense records of travel check-in in hometown and local check-in in current city, PIUDIT is able to achieve more accurate predictions on travelers' future check-ins in current cities. PIUDIT, the general framework, can be applied to different loss functions. Here we consider 2 widely used loss functions, square error-based model and a ranking error-based model. The experiment shown that the proposed PR unity framework, after combined with two specific models, can outperform the other baseline by a large margin. Moreover, universal is a flexibility in multi-city scenarios, where the user can travel among multiple cities. Again, a consistent performance again is observed in this experiment. Finally, to conclude, our proposed PR utility is the first to combine user interest drift the transfer in cross-city PR recommendation. It can achieve significant performance gain according to our experiments. In the future, we plan to leverage more rich information to handle data sparsity issue in this problem and achieve better trade-off between interest drift and transfer. Thank you.